Hi, welcome to Project Geospatial. I'm Adam Simmons, and here with me, I have the pleasure of speaking with Ben Tuttle, Chief Technology Officer at EOI Space. Ben, thank you for talking with us today, and please go ahead and introduce yourself and give us some insights of your history in the industry, because I know it's been pretty extensive at this point.
Right on. Thanks, Adam. Appreciate you having me. I go back a ways. I was born to two civil servants who maybe taught me that giving back in that way was a good thing. Came up as a technology geek. My parents sent me to programming camp when I was 6. And then I discovered remote sensing when I was about 12 with a family friend at EPA who back then imagery analysis meant printing it on paper and drawing on it with a pen. So it's been an interesting ride since then. I've sort of spent my career bringing those two things, technology and remote sensing, together to always be looking for new ways to help people make better, faster, cheaper decisions and keep that part of things moving. So any opportunity to leverage the latest in technology and the latest in remote sensing data usually gets me excited. Started my career off as research faculty at CU Boulder, working with NOAA on the nighttime lights, and love your background. It's a big part of my life. Went on from there to grad school, got my master's in GIS, PhD in remote sensing, and during that time moved over to working at the National Geospatial Intelligence Agency. Was there for about 10 years. Went through a number of different roles and had a great time. And then left there to join a small startup called Arturo. It was doing property analytics on aerial imagery for insurance companies. So really exciting to do, computer vision and deep learning to be able to analyze a property in under 10 seconds without a human in the loop. And then last year came over to EOI Space and just was really excited about what they were doing and couldn't say no to the opportunity that they present.
Excellent. Well, let's talk about EOI Space. Who are they, and where did they come from? I mean, I say that as if they haven't been around for the last couple of years, but
indeed,
let's talk about what do they provide. All I know they're an EO satellite collector, correct?
Yes. So the company has been around several years. We just really came out publicly last year and started really talking about the company. It actually started off, the two co-founders used to work a propulsion company, building propulsion for other satellites. And they came up with some very interesting designs for a head-X thruster that they decided would be very interesting to operate at super low altitudes. And they started wondering, well, maybe instead of just selling thrusters to other people, we can start a business off of this. And they started doing some research and found that nobody was really exploring this Earth observation from very low Earth orbit concept. So they started around that and built a bus design that is specifically built with that thruster in mind and built with VLEO in mind. So that's a key part of the underpinnings of why this works, is having that unique build that is designed to operate at this orbit. And then they started hiring. They decided to base the company here in Louisville, Colorado, since the Front Range is a spectacular spot for aerospace talent. So we have a large facility with our clean room in Louisville where we are building out the first spacecraft right now, getting ready for launch next year. And we will be flying somewhere between 250 and 300 kilometers, collecting 15 centimeter or better resolution pan, RGB, and near IR data. That's not pan sharpened. That's in fact 15 centimeter or better at each one of those bands. We have a very interesting payload that is sort of new to the scene that we're very excited about. And our primary target is to sell collection time. So we already have a deal in place with some folks in Japan on this. And it's basically they get guaranteed minutes of collection time that they can schedule over an AOI that they've chosen. And that's our signature Cadillac product. We'll also have on-demand tasking and library access and things like that. But that's sort of the high-end premium product that we're offering. And super excited about the opportunities that brings people to ensure they are getting collection over the areas they really need it. We know, there's a lot of people in the industry, in government, international government, private, who don't always get the imagery they need because of limited capacity. We're really aiming to bring the highest capacity available by having a constellation of 60 satellites, the highest resolution available at 15 centimeters or better, as well as extremely high revisit. With that 60 satellite constellation, looking at 70 degrees off nadir, we'll be able to revisit a target about every 8 minutes.
Every 8 minutes. Wow. That's incredible. Okay. So that's a game changer right now. I was trying to, so let's kind of go back to the low Earth orbit. There's a number of other companies out there who do low Earth orbit satellites nowadays. But how unique is what you provide for low Earth orbit compared to everybody else? And why is that a important point to bring forward?
Yeah. So, traditionally people are flying between 500 and 600 kilometers. You've got Black Sky now flying down in the 400s, 300s. There's an announcement from them yesterday that they're going to lower a couple of their satellites even lower into the 300s, but we're going to be 300 or lower. So we are way down in the atmosphere. And so specifically the bus is designed to handle operating in that high drag environment. It allows us to have a smaller satellite with an impressive payload that gets much higher resolution than we could get from 500 or even from 350. And because of the thrusting system and operating at that altitude, we have to thrust and drag throughout the day to maintain the orbit. The satellite won't naturally maintain that orbit on its own. After about 3 weeks without thrusting, it would lose its orbit and be irrecoverable. But using that, we're able to take advantage of potentially doing unwarned collect and things like that, because we don't pass over a place at the exact same time. Using the scheduling of when we thrust and drag, we can alter coming over a place sooner than expected or later than expected.
Incredible. So how about the near infrared portion? So I caught that. Obviously, you were noting the background behind me. I'm actually pretty excited to hear you say near infrared, because a lot of companies like wrapping that up with the whole multispectral, hyperspectral spectrum, and that kind of advantage kind of gets lost in the wind.
Absolutely.
So what is your play with infrared? Are you going to dip into the nighttime a bit, or is it going to stay fully daytime?
So obviously daytime is the first play, but our NOAA license includes nighttime. And we're allowed to sell nighttime at 70 centimeters. Based on our current NOAA license.
That's incredible.
I think that's pretty exciting. And yes, given that I spent 10 years of my early career doing nighttime lights work, really excited about the potential there to bring high resolution, low light imaging and see what we can do there. Lots of opportunities that we're exploring.
So with everything that you just said, what is the current status of all these things? Obviously you don't have 60 up just yet.
Yeah.
so how far along in this progression of the roadmap are you right now?
Yeah. So indeed, it takes some time, right, to build this out. Right now we're building the first spacecraft in our clean room, as I mentioned, and that's scheduled to launch in 2024. And then we've also got rides booked for 5 more satellites in 2025.
Excellent.
Ultimately, in 2026, our goal is to move to building and launching 12 of these a year. So I believe that puts us around 2029 or so, that would be looking at starting to hit that 60 number.
Great. And I'm sure you have a cadence, because it's low Earth orbit. These things are going to fall out, and you're going to have a iterative, adaptation and generational improvement. Right?
Absolutely.
Great.
Yeah. So we're thinking every year there'll be a new rev of the satellite. Whether that's advances in solar components or things we figure out with the thruster, as well as we're putting a very significant amount of on-orbit compute on every satellite. And at the pace that those computers are advancing every year, we're going to see significant increases in the ability of the satellites to do on-orbit analytics and processing.
So the analytics will be ready. You're just basically downlinking all the data that needs to be used right away, rather than waiting for it to come down to the ground station first.
Yes. One of our goals is to help people make decisions faster. Like I said, that's been one of my career goals all my life. And by processing on board, we'll be able to get a georeferenced or orthorectified imagery straight to a user on the ground, which also means potentially down the road, imagine delivering orthorectified imagery to a warfighter in theater within 10 minutes of collect. That gets really exciting. In addition, because of the nature of our sensor, we're able to track motion when we capture. And using that on-orbit compute, we'll be able to extract motion tracking indicators and embed that as metadata in the imagery when we send it down.
Now, what's your perspective on this? You have a bunch of satellites coming around the corner, but on the other hand, you have plenty of time to build out your platform and what it means. Now, with the amount of data and the frequency of collects, it's going to be a game changer in terms of how your customers interact, order, and try to and try to retrieve that data and order it for you. So how I'm sure you're still thinking about ways on what that means for your customers, right? And in emerging ways.
Yeah, I mean, that's one of the really exciting parts about where this is going, right? We all know the current NGA director refers to it as the data deluge. I've heard lots of people call it pixel glut. But how are we going to do this? How are we going to deal with this amount of data? These satellites at full collection capacity that we're talking about will generate 85 terabytes of uncompressed imagery a day. So like you said, it's an insane amount of data and there's not enough people to look at it all.
Well,
so
no one wants to look at a sea of footprints trying to order their one or two images or their stack of images too. What's the best way to even do that from an ordering, collection management standpoint,
Yeah. So we're imagining, some changes in how one thinks about collection and tasking. Using that on-orbit compute, right, we'll be able to run models and computer vision algorithms on the satellite and perhaps say, you know what, I only want you to downlink this image if this change has happened. I only want you to downlink this image for me if this tank has moved from this part of the garrison to another. And then even more exciting, well, I want to know when this ship leaves this port, but I don't actually care about that image. What I really want to know is which of these other 3 ports does it arrive at and when after it leaves. And using the on-orbit compute, we could start tasking other satellites to start going after that based on acknowledging the first moment, which is the ship leaving the first port.
So
and then we only downlink
machine learning algorithms. You're going to downlink machine learning algorithms directly with your onboard computing.
Yes.
Wow, that's exactly. Okay. That's an incredible story to tell right there.
Yeah. And one of the key things, I'm a firm believer, and this company, EOI, is a firm believer that no one company can solve all the world's analytics or data problems. We're not going to try and convince everybody that we're the holy grail, and if you just come to us, we will solve everything. So in building this on-orbit compute cluster, we are going out of our way to make it secure. It's going to be CMMC compliant out of the box. And one of our hopes is that we will be able to find analytics partners that are already working with the government or groups like Maven that are building algorithms of their own that we would be able to take to the satellite rather than us trying to build every single analytic ourselves. We don't think that's a good idea or that it's good for the user. So we're very excited to find partnerships to bring the most amazing analytics to bear.
Awesome. No, that's incredible. So you all are about to go to GEOINT, the GEOINT symposium coming up. So obviously this is still a little bit outside of your purview, but the concept of the metaverse, maybe this isn't, with the amount of data that you're bringing into the table here, everything you're doing could directly feed this in a very dynamic way. 8-minute image collects. I mean, you're looking at a very dynamic future towards digital twins going down the road.
Yes. Yeah, I think of Al Gore's Digital Earth vision, Neil Stephens's Snow Crash Globe. We're really moving towards that right now, right? And exactly, we could be bringing data in much faster times than people are used to, in very large quantities, and we can get shots from 0 to 70 degrees. So at 70 degrees, you can do some awesome stuff like look into a hangar or look through a carport. As well as start using that to create 3D reconstructions. And we're even exploring some opportunities where because of the nature of our sensor, which is the super IP here, and I won't get into too much detail on, but we may have an opportunity to do 3D even with a single shot.
Wow, that's it. What's incredible. So
another research opportunity.
Well, going back to the constellation a little bit from the, not just the revisit rate, but, how far across a region with how many satellites are projected to be in orbit, can you actually track an object? If a car is moving across a region, can you continuously keep an eye on that, over a course of time? What types of scenarios are we looking at there with the increased revisit rate and the amount of satellites that you have?
Yeah, potentially, right? And especially with that on-orbit compute, if you find the car and you want to track it, being able to tip the next satellite without having to wait for that to go to a ground station, get observed by a person, and then sent back as another task. Being able to do that tasking in real time on orbit makes that potentially possible. Our initial satellites will be flying all sun synchronous, but we're planning to do other mid-and-planned orbits with other satellites in the future of the constellation. So we'll have a mix of different orbits available to us that should be interesting for doing some of that work and doing chain of custody of a target from space.
Excellent. Is this you're going to have polar orbits as well, or are you just?
Yeah. So the first ones will be polar sun synchronous, but then we're looking at 55, 45, some other inclinations like that, so that we can get different angles and different pastimes and views of things.
Awesome. Well, I appreciate all the knowledge you're giving us on EOI space. Is there any last minute plugs you'd like to give for the company, what you're trying to achieve moving forward, or perhaps maybe where you see the industry going with all this new tech coming around the corner?
Yeah, you can find us online at eoi.space, and you'll be able to find us around the GEOINT Symposium and other exciting conferences coming to a venue near you in the coming year. We'll be launching in 2024. And I think, as the industry goes, one of the things I'm really excited about is with these new on-orbit networks that'll allow us to communicate with more on-orbit compute, we're really excited about the potential to not just do that smart tipping and queuing through our constellation, but to do that smart tipping and queuing across many constellations, bringing in different phenomenologies so that we can really solve the problems that are important to the warfighter and getting that out, and as well as helping the intelligence community get the latest and greatest, best imagery possible, and start delving into this space that was once only available from aircraft.
Excellent. Well, Ben, thank you for joining us. Once again, I'm Adam Smith of Project Geospatial here with Ben Tuttle, CTO at EOI Space. We'll talk to everybody next time.